So I know not everyone is crazy about math, but Ohm's law is quite important in understanding the basics of electronics and robotics. Think of it as your little helper training wheels when you first get started. As you get more experience and you get more professional in your craft, you're going to start guessing resistor values quite accurately. So for myself, I generally don't do this equation. I have a thumb suck rule of resistor values that I do use on certain voltages, but there is a way of getting the exact resistor value. So let's have a look at that. This is Ohm's law I've been talking about. Now, as you can see here, it's a basic formula in calculating any given value, volts, amps, or resistance if any other two values have been given. Now we can see here that volt is equal to amps times resistance. Amps is equal to volts divided by resistance, and resistance is equal to volt divided by amps. An easy way of remembering this is drawing this little triangle to show you the relationships between these values. But what does this mean for us? How will we be using this to calculate LEDs? Now, LEDs have a thing called a forward voltage. Each color of each LED has a different forward voltage and thus will have a different resistance value. So, and all of them, we can generalize them at a current draw of about 20 milliamps. So here we have all of the different forward voltage values for different LED colors. As you can see here, green has a forward voltage of 1.9 volts, red has a forward voltage of 1.6 volts, and what clear white is 3.5, blue 2.4, and yellow 2.1. So what we're going to be using is this formula right here, because we want to calculate the resistor value. Now, the resistor value is still unknown, but we do have these other values. So LEDs can draw a maximum of 20 milliamps before they blow. So we know that each LED draws 20 milliamps and they have different voltages respectively. So now we can fill these into the formula and thus calculate the resistor values that we are going to need for each LED. So let's start off with green and see if our calculations are correct and if they indeed work. So we're going to go here and say R is still unknown. Is equal to volts, which is 1.9 volts there, 1.9 volts, divided by current. Now remember that this current is in amps, and we know the voltage in milliamps. So how you do this, you divide it by 1,000 to get amps to milliamps. So 20 divided by 1,000 is 0.02. There we go. And thus we now have it converted to amps. So R is going to be equal to 1.9 divided by 0.02. So R is going to be equal to, as you can see here, the result is 95 ohms. Now you might not have an exact 95 ohm resistor, so I do recommend always going a bit higher than the actual value that you have gotten here, as your LED is going to be running at maximum brightness, reducing the lifespan of the LED by a few years. So I'm going to go ahead and use a 100 ohm resistor, but I do generally recommending something in the range of 150 to 220. So let's have a look if our 100 ohm resistor is going to do the job according to our calculations. Here is our 100 ohm resistor, says 100R. I'm going to go ahead and remove this LED right here, or the resistor. I'm going to plug it in, plug in our LED on our board, making sure that the longer leg is going to our positive side. And from the negative leg right here, we're adding in our resistor. There we go. Our LED turns on. It's shining at maximum brightness and it's working great. So we can do another example just to get you guys cleared up on this and better started. So let's do the red LED next and see if we can calculate its resistance. We're still going to be using the same formula where we have R. It's equal to volts, which is 1.6 volts right here, divided by, we have our 20 milliamps, which we've already converted to amps. So divided by 0,02 amps. And from here, we can say respectively that resistance is going to be equal to 1.6 divided by 0,02. And it's going to be equal to an 80 ohm resistor. Now, I unfortunately do not have an 80 ohm resistor, but I'm going to be testing our theory with the 100 ohm again and seeing if that works. And there we go. All of our LEDs should turn on this voltage and on the current that we are running them on. So there we go. All of them are working perfectly. So this is how you can calculate LED resistor values with a bit of mathematics. If you don't want to calculate it, here are my general rules. So for 5 volts, I do recommend a 220 ohm resistor. This is going to be very generalized. For 12 volts, I recommend a 560 ohm resistor, and on 3.3 volts, something like a 100 ohm resistor works very well. So those are my voltages I have, which are general thumb suck values. I don't generally get the best brightness out of my LEDs, but this tends to work fine for most applications, depending on what you're trying to do. Thank you so much for watching our video on Ohm's law, guys. I really hope you did learn a lot. You're going to be referring back to this video quite a lot in the future, as this is one of the most important principles in electronics and robotics to understand. So thank you yet again for watching. Please remember to like and subscribe, and I'll see you guys next time.